I'm Supriya Lohar, working as an assistant professor at All India Shri Shivaji Memorial Society's Institute of Information Technology. I'm going to talk about E PlaneTee. Microwave T junctions. So now E PlaneTee is a microwave T junction. A junction is an intersection of three waveguides in the form of English alphabet T. It's having three different types. First one is H PlaneTee, second one is E PlaneTee, third one is EH, that is hybrid or magic T. Today I'm going to talk about E PlaneTee. A rectangular slot is cut along the border dimension of a waveguide and a side arm is attached. Port 1 and port 2 are collinear arms, that is the main waveguide, and port 3 is E arm. When TE10 mode is mode to propagate into port 3, the two outputs at port 1 and port 2 will have a phase shift of 180 degree. Since the electric field lines change their direction when they come out of port 1 and port 2, it is called as a E PlaneTee. E PlaneTee is a voltage or series junction symmetrical about the central arm. Hence, any signal that is to be split or any two signals that are to be combined will fed into the E arm. In general, the power out of port 3, that is E arm, is proportional to the difference between instantaneous power entering from port 1 and port 2. Also, the effective value of the power leaving E arm is proportional to the phasor difference between the powers entering port 1 and port 2. When powers entering the main arm, that is a port 1 and port 2, are in phase opposition and maximum energy comes out of the port 3, that is the E arm. Scattering matrix of the plane T will describe all its properties. As we know this basic equation, B is equal to S into A. B is all the outputs of the E PlaneTee. S is the scattering matrix of the E PlaneTee, and A is all inputs of the E PlaneTee. So from this equation, what we get is three equations for the output of a E PlaneTee. Now we are going to consider different combinations of the input in order to get the different outputs. So case 1, we are applying input at the port 3, that is A3 is, we are applying input at port 3, that is A3, and input at port 1 and port 2 will be 0, that is A1 and A2 will be 0. So if we substitute these values in previous equations of the output of the E PlaneTee, what we get is B1 is equal to A3 by root 2 and B2 is equal to minus A3 by root 2. B3 is equal to 0. An input at port 3 equally divides between port 1 and port 2, but introduces an phase shift of the 180 degree between two outputs. Hence, E PlaneTee also acts as a 3 dB splitter. Consider case 2. Where A1 is equal to A2 is equal to A and in A3 is equal to 0. So we are applying inputs at the port 1 and port 2, which are the same input, and we are applying nothing at the port 3. So if we substitute these values of the inputs in previous basic equation, B is equal to